Welcome to MRU E-Learning, powered by Malla Reddy University. Myself, Arpita Rani, Assistant Professor from the Department of Cybersecurity and IoT. Today we are going to the session of modeling concepts of UML. Before discussing the modeling concepts of UML, we need to discuss about what is UML. So the full form of UML is Unified Modeling Language. It is a standardized visual modeling language which is used to specify, visualize, and also construct and also document the artifacts. So we are able to see the three aspects of UML. One is language, model, and unified. So here when we are discussing about these three, these are the three things which are considering to build the diagrams based on unified approach, which consists of bringing together the information system and technology industry's best engineering practices. So whatever the information system we have, based on the best engineering practices, we are going to build whatever the design or whatever the model. So next one we are going to see is model, in which it is representing a subject, or we can also consider an idea, which is also known as abstractions. So nothing but artifact of a particular model or a system. The next thing which we are going to specify about the language. So what is a language? Normally language means we consider it as a programming languages like C, C++, Java, COBOL. But here in unified modeling language, language is considered to be a visualization effects. So here it is enabling the communication through visualization. So whatever the model we are representing, that model is explained or communicated to the users through the language which is called as visualization language. So these are the three important pillars we consider for the designing of any artifact. And we can see mainly the concepts of modeling in UML. We discuss about three parts. One is basic building blocks. Second thing is rules. Third thing is common mechanisms. Whereas basic building blocks are the main building blocks based on which we are going to draw the diagrams. Nothing but we are going for modeling. But in order to model any kind of a design, we are going to follow particularly rules. These rules are indicating what are the do's and what are the don'ts we need to follow in framing or in modeling the concepts. And whenever we are going through this unified modeling language, we follow some common mechanisms which are already existing and we are using them in the building blocks. So today we will deliberately see about the common mechanisms and building blocks. So here the basic building blocks are considering with three specifications. First one is things, second one is relationships, third one is diagrams. These together we are going to show the specification of UML. Now whenever we discuss about things, things consist of four aspects: structural things, behavioral things, grouping things, annotational things. Whereas in relationships also, we are going to provide about relations, how these components are connected with each other. Those are association, dependency, generalization, and realization. And we are dividing the diagrams into two parts: structural diagrams and behavioral diagrams. We will discuss one by one with detail. Now when we are discussing about things, as I told you, it consists of four things, and these things are representing abstractions, whereas it provides how it looks and what are the relationship, how they are combining or how they are relating with each other. Now, as I told you that there are 4 types of things: structural things, behavioral things, grouping things, and notational things. First, we will start with structural things. These structural things represent static in nature. Static in nature. What is meant by static in nature? We are representing components of a system. Static means we are representing components of a system and how they are related with each other. For example, if you take an ATM is an application, in that application, the static behavior consists of components. What will be the components? Example, you can take ATM is one component, account is another component, and card is also another component which will be existing forever. And this structural things consists of main specification of classes, objects, interface, collaboration, use case, active class, components, and also nodes. Mainly these notations help us going through diagrams or to build the diagrams. Next, first thing in structural, class notation. How to draw the class notation? Whenever we represent UML class, it is represented by dividing the figure. You can see the here class diagram, which is divided into 4 parts or 4 sections. The top section is consisting the class name. The top section is consisting the class name, and the second part of the class notation consists of information, which is considered to be known as attributes. And the third part of the class notation consists of operations, nothing but functionalities. And fourth part is considered to be optional. Whereas, so here you can see a class is nothing but a blueprint of an object which consists of its properties and methods or functionalities. Normally, classes are used to represent the objects, and objects can be anything having the properties and responsibilities. Whereas next notation we are going to discuss is object notation. So object notation is similar to class. It is represented in the same way as the class. The only difference in the notation of class and object is, here you can see the name of the object is underlined. The name of the class is not underlined. The name of the object is underlined. Where it also consists of similarly another 2 important parts. They are information, nothing but attributes, and operations. You can see here the symbols plus, hash, minus, these are indicating the specification of public, private, and protected access specifiers. If you want to mention in the diagrammatic representation, we are mentioning with these symbols. Third thing is interface notation. So what is meant by an interface? Which consists of abstract methods. Now that means it consists of functionality without implementation. So whenever we need to provide the interface specification in a diagram, we need to use the symbol of circle, where it consists the interface and also you are able to specify the description of the functionality. So whenever we want to implement the functionality of an interface, we can combine this symbol with a class notation. Next one is collaboration. So collaboration is represented by dotted ellipse as shown in the following figure. It has a name written inside the symbol where it consists of group of responsibilities. So you can also mention additional components which can be classified in this collaboration symbol or representation. Next one is use case notation. Use case is represented as an ellipse with the name inside. This use case is mostly used in use case diagram, and use case is used to capture high level functionalities of a system. So whatever the functionalities of a system is there, you are going to represent within the use case. Next thing is actor. So whenever we represent use case diagram, very important things are use cases and actors. So where actor is represented with this notation. And why do we use actors? Because a system consists of external entities and internal entities. So the entities which are external or internal communicating towards a system are represented by using the actor notation. The next one notation is initial state notation, whereas whenever we go through flow of actions or activities, the process starts with the initial process where we indicate this initial state. So this notation is almost used in most of the diagrams, and the usage of initial notation is to show the starting point of the process. The next one is final state notation. As the name it is indicating, the final state notation is indicating the last termination of the process. It is used to show the end of the process, and this is also used in most of the diagrams of UML. Next one is active class notation. So active class notation looks similar to a class. What is the difference you are observing from class notation and active class notation? Boundaries are thick, broad, or solid border is drawn around the attributes and properties. So you can see here in the active class, it is representing the concurrency of a system. Whenever we want to represent the concurrent behavior of a system, we will be using the active class. The next one is component notation. So the component notation is used in UML in order to show the part of a system. Whenever we want to represent any part of a system, we will be using the component diagram. The notation is represented in this manner, and these components can have interaction. We can represent the relation between these components also. The next notation here is node notation. So whenever we see node notation, why do we use this notation? To represent physical part of the system. In order to represent the physical part of the system, we use the node notation. Whereas example, we can say about a server or a network, any physical part of a system we need to establish, we need to explain, we can go through this notation. That is node notation, which is in the form of cubic. So previously we have discussed structural things, which is representing the static behavior, nothing but components of a system. Now we are discussing about behavioral things. What these behavioral things consists of? It consists of dynamic parts of UML diagrams. So what is meant by dynamic parts of UML diagrams? It explains you about the actions or activities which are performed. For example, if you take a ATM as an example, we will be inserting the ATM, we will be entering the PIN, we will be withdrawing the cash. So all these are considered to be dynamic in nature. That means timely they are changing. So dynamic aspects we will be representing through behavioral things. What comes under behavioral things? Because whenever we want to perform a communication or interaction, action we need to perform, in that case we need to provide a communication or interaction, either component to component or entity to component also. So in that we have two specifications. First one is interaction, which is indicating the behavior, that consists of group of messages exchanged among elements to accomplish a specific task. The next one is state machine. It is useful when the state of an object in its life cycle is important. It defines a sequence of states an object goes through in response to events. Events are external factors responsible for state change. You can see the notation we are representing for state here. The next one is grouping things. So we see in grouping things a mechanism which consists of group of elements. In UML, we put a group of elements together. So what is this notation we will be using for group of elements is nothing but a package. A package is representing group of things available for gathering structural and behavioral things. So this is the notation we will be using for package, a folder like a symbol. The next, whenever we are representing an artifact simulation or a scale model, we will be able to explain. For example, sometimes we want to explain about the visualization regarding its information or regarding the rules to be followed or regarding the comments. So these are specified through annotational things in which we use note. So this note is helpful for writing a textual format in that, which consists of comments, rules, remarks, all these specifications, or else we can go for constraints also. The next building block is UML relationships. Relationships depict a connection between several things such as structural, behavioral, or grouping things in unified modeling language. Since it is termed as a link, it demonstrates how things are interrelated to each other at the time of system execution. It means whenever we are representing a static representation, nothing but a components and their relationship or else interaction between components, we need to specify through a relationship. So here it consists of 4 types of relationships. First one is dependency, association, generalization, and realization. The first relation is dependency. Dependency depicts how various things within a system are dependent on each other. In UML, a dependency relationship is the kind of relationship in which a client is dependent on the supplier. For example, if you see here, we have taken a client class and the supplier class. Now here, client is dependent on the supplier. So that symbol we are using the dependency. So dependency is always shown with the dashed line with the arrow mark. So it is mostly used in class diagrams, component diagrams, deployment diagrams, and use case diagrams, because these all represents the relation components, which indicates that a change to the supplier necessities can change the client class. So for example, if you see whatever the changes we make in the supplier, that affects client. So client is dependent on the supplier. So this kind of relation, if you want to exhibit, we need to use a dependency symbol. Next, association. When do we use association notation? In UML diagrams, an association class is a class that is a part of an association relationship between 2 other classes. For example, if you see here, student is one class, course is another class. Whereas we are specifying a relationship between student and class through association. Student is associated with the class. But if you want to specify an association class here, we need to use a association class which is linked to association. So it is represented with a dashed line. And you can see here how they are related. One student is able to register for one course. You are going to provide one-to-one relationship here. So in association, we have different types of association. One of the association is reflexive association. So in the reflexive associations, the links are between the objects of the same classes. It can be said that the reflexive association consists of same class at both ends. It indicates that Here you can see a vegetable is the class, and here you have taken we have taken two classes. One is onion and the other is eggplant. So these two classes are considered to be objects or child classes of main class or parent class vegetable. So how these two classes are related to each other? These two classes are related to each other because they are inherited from the same parent. So whenever we want to exhibit this kind of relation, we use reflexive association. That means they have a relation based on their parent. Next one is directed association. So if you see, directed association is concerned with the direction of flow inside association class. So this is indicating the direction. So in this diagram, in this notation, you can see here, a person is directly associated with a company because a person works for a company. So that person is directly associated with the company. So in this case also is so. Next relation is generalization. So generalization relationship is a relationship that implements the concept of object orientation called inheritance. So in this we can see, whenever we see the child which is inheriting the functionalities of the parent and can access as well as update it. That means one subclass can inherit the properties of its parent class so that it can have its own properties and also inherited properties from the parent. So whenever we want to show this kind of relationship between a child class and parent class, we mostly use generalization. For example, if we take courses, CSE is the course. So what are the specialized courses in this? We will represent through this notation using cybersecurity is one of the specialized course, IoT is another specialized course, data science is another specialized courses. So like this notation is representing specialization. Whereas in general, if you want to represent, we will be using this CSE is the parent class. So generalized class for all the specialized classes, from all the specialized classes. Like this we will be representing. So this notation is considered to be, this notation is considered to be generalization. Okay. Next one is realization. When do we use this kind of relationship? When there is an interface which is only consisting of functionality but not implementation. So if you want to implement the functionalities declared in the interface, we use the class, whereas we are going for extensibility. So this extensibility realization can be represented with the dashed line followed by halo arrow mark. So this is the representation we are using. Next. So now we have discussed in the building blocks, things and relationships. Now we are discussing the third part of building blocks, very important, types of UML diagrams. When we discuss UML diagrams, we classify them into two types of diagrams. One is structural UML diagrams and other one is behavioral UML diagrams. As we discussed earlier, it represents structural UML diagrams consists of static aspects, where it consists of components and relationship among them. Behavioral UML diagrams consists of dynamic in nature and represent timely changes. So here what comes under the structural UML diagrams? Class diagram, object diagram, component diagram, composite structure diagram, deployment diagram, package diagram, profile diagram. What comes under the behavioral UML diagrams? Activity diagram, use case diagram, interaction overview diagram, timing diagram, communication diagram, state machine diagram, sequence diagram. So UML diagrams are the ultimate output of the entire specification, where all the elements, relationships are used to make a complete UML diagram, where the visual effect of the UML diagram is the most important part of the entire process. All the other elements are used to make it complete. So today we are going to discuss about these diagrams: class diagram, object diagram, use case diagram, sequence collaboration diagrams. These diagrams comes under interaction diagrams. Interaction diagram. So we discuss sequence diagram here. Activity diagram, state chart diagram, deployment diagram, and a component diagram. We will discuss one by one. The first diagram is class diagram. We use class diagram to depict the static structure of a system by showing system's classes, their methods, and attributes. Class diagrams also help us identify relationship between different classes or objects. So whenever we see class diagram, as previously we have discussed the class notation, it consists of multiple classes, where in this example you can see ordering a menu. You can see here a customer who is ordering. So the customer consists of its own attributes and properties. Order class consists of its own properties and methods. And we are providing that order is based on the customer. So here association is directed association, and one customer can order many number of orders. So we can specify in this manner. Whereas you can see here generalization concept, where order is considered to be superclass, and here special order and normal order are considered to be subclasses. So this is providing generalization relationship. So here we have used in the class diagram multiple components, nothing but taken as classes, and relationship among these components. So we say class is the blueprint of an object. So here we can see an object diagram which is similar to class diagram, except it shows the instances of classes in the system. We depict actual classifiers and their responsibilities or relationships, making the use of class diagram. On the other hand, an object diagram represents specific instances of a classes and relationship between them at a point of time. Here, college A is indicating the object name, and here college is indicating the class name. Either we can represent in this manner, or we can represent only the object name which is consisting underlined, as we discussed in object notation. Now here college A object is relating with the student 3030, that is 3030, which is related with the college. So here we are providing an association relationship, and usually how the class consists, the object also consists of the properties, and here you can see student object also consists of properties. Next one is use case diagram. So in the use case diagram, we mostly use actors, use cases, and we also see a relationship between them. So use case diagram are useful in several situations. And when do we use these use case diagrams? When you need to gather and clarify user requirements. Use case diagrams help to visualize how different users interact with the system. If you are working with diverse groups, including non-technical stakeholders, these diagrams provide a specific, clear, and simple way to convey system functionality. And also, whenever you are designing the system, this system design phase, the use case diagram helps to outline the user interactions and also design aligns with the user needs. Still, when defining what is included in the system versus what is a external use case diagram help clarify these boundaries. Now in this example, we have seen online shopping system where we have seen a web customer. So here a web customer is the parent entity which consists of inherited to a new customer and the registered customer. Here new customer is indicating the customer who is not yet registered. So if a registered customer is there, what are the tasks which are performed by the registered customer? He can view the item, this is represented as use case. He can view the items, then he can make a purchase. So if he have to purchase, he need to mention the items in the cart. So here the include stereotype, common mechanism we have discussed, no? So in the common mechanism we use a stereotype. So this symbol is indicating the stereotype. So in this we are mentioning include. What does that mean? Whenever there is a requirement of mandatory tasks to be performed, we use include. So here for example, if you want to make a purchase compulsory need to view items. If there are items in the cart, then only you are able to make a purchase. If you want to check out, for example, if you want to make a purchase, compulsory you need to go for a checkout. So it is a mandatory option. It is a mandatory option which we need to go through, which is specified through include. If there is an optional specification like need or not to needed, we can use another specification which is called as extends. It is not a mandatory option. So it is optional, we can consider. Then after checking out, the user's web customer's task is completed. Whereas we have another entities which are communicating. In use case diagram, we see the actors, internal entities or external entities. So here another entities which are communicating with the system are service authentication, identity provider, credit payment service and PayPal. So here whenever they are going for registering these authentication, another service authenticator will be providing the authentication. Identity provider will check the identity of the user and also provides the identity. And credit PayPal service also will authenticate the payment and also can provide the service. So like this, each and every entity is communicating with the system. So this box is representing the system, this is representing the use case, and this symbol is representing, notation is representing the actors. And here you can see how they are related. Each relationship is mentioned. Next diagram is sequence diagram. So sequence diagram provides a detailed visualization of the interaction between objects or components, focusing on their sequential ordering and timing. This consists of dynamic behavior by showing how objects interact, helping to communicate the system behavior. What is the purpose of this sequence diagram? It illustrates interactions and measures flows between objects. It shows the sequence of operations over time, and it helps understanding use cases, design system, architecture and document process. So here you can consider this example where you can see these are the objects, application, authentication server and back server, and there is an actor, an entity communicating with the system. So in this we can consider this as a lifeline. which consists of dotted symbol. Whereas this notation is indicating activation bar. That means the active time where the communication is available. Then we can see here a communication. So actor is communicating, that is customer is communicating with the application by login. So here when he is login, he have to enter a password. That password which is entered by the customer is verified by the authentication service. After verifying, it will return with the JWT, which is indicating whether the entered password is valid or invalid. So if it is a valid, it will allow the customer to check the balance. If it is invalid, it will not allow to check the balance. Once he can go for checking the balance through application, he can go for balance inquiry. And the bank server will be providing the return balance. Here you are able to see the messages which are forward direction and backward direction. When customer is communicating, that means requesting a login, this kind of communication is called as a message, a request message. And when through application, when a response is sent to customer, it is in the dashed line arrow mark is there. So which is indicating a reply message. So if you see this kind of communication, that is requesting a message and there is a response for the message. This kind of communication of message is known as synchronous message. If there is a message without any response, that kind of message is considered to be asynchronous message. So here we see objects, its lifetime and a communication interaction, and the interaction also how it will be in a sequence order and timely. That means, for example, you have logged in at 10:01, but verification of password and takes place at 10:02. So it will be timely duration and step by step interaction is done one after the another. So the time interval between them will be different. So that's the reason we call it as a interaction diagram with the specification of sequential order and timing. So this diagram, sequence diagram, comes under the behavioral thing or behavioral diagrams. The next diagram is activity diagram. So activity diagram is basically a flow chart to represent the flow of one activity to another activity. The activity can describe an operation of the system. So whenever we go with the flow diagrams or data flow diagrams, flow charts we will be represented. Normally activity diagram is similar to that. What is the purpose of this activity diagram? To draw the activities in flow of a system, we use it. To describe the sequence from one activity to another activity. And also to describe the parallel, branched and concurrent flow of a system also we will be using. In this diagram, what are the notation we will be using in the activity diagram? Here, this notation is indicating initial state and this is indicating action box, decision box and also final state. And we also use two more notations called as fork and join. Whenever there are multiple options among which the user or the entity need to choose one, we will be using fork option. So like this we will be representing. So whenever we need to communicate through one particular action among these, we will be using join. This is considered to be join and this is considered to be fork. Where you can see in this example, we have a customer, ATM machine and a bank. So we are starting the process with the initial node, which is indicating it is just a start of the process, where we perform an action by inserting the card. So this is considered to be action box, which shows the state of action. Next, after inserting the card, the other activity which we are performing is we enter the PIN. Once the customer is entering the PIN, that PIN is valid or not, which is authenticated by the authorized person of the bank or authorized specification of the bank. So once the bank will verify whether it is PIN is valid or not. For example, if the customer entered invalid password or invalid PIN, it takes you to the termination of the application or termination of the process. Nothing but eject card, remove the card. The next one is if you have entered the valid PIN, then it will allow the another flow of action to perform any check account balance. You have selected check account balance. For example, if the account balance is less than the amount you want to withdraw, it will go for again show balance and then eject card. If the balance is greater than the amount which you want to deduct, then it will be giving two options to you, whether you want to go for cash withdrawal or whether you want to deposit into another account. So here this symbol is considered to be known as fork, where you can see multiple options it is providing. So if you can select this one or you can select this one. Whereas though any one you are selecting, the next thing is joining these two options, which is called as join node, through which you are able to make a decision after withdrawal or after debiting the account to another account. You can go for show balance, then eject the card, then select the eject card, then go for taking the card. So like this you are performing the activity diagram. The next diagram is state chart diagram. A state chart diagram describes a state machine where you can see it is defined as a machine which defines different states of an object, and these states are controlled by external or internal events. What is the purpose of state chart diagram? To model the dynamic aspects of the system, to model the lifetime of the reactive system, to describe different states of an object during its lifetime, defining of state machine to model the state of an object. So it will be representing in which state in the process you are in. So if you take the example of state chart diagram, here you can see this is the initial node where you are in start, and that means you are in which state? Ideal state. From the ideal state you are going for ordering a request. So here we are discussing about order management system. From ideal state to you are going for ordering of a request. After ordering of request, it can be selecting based on a normal order or special order. So once the order is confirmed, so the order confirmation is done, you are in the state of order confirmation and dispatch of order. Then once the transaction is completed, you will come to the final state, which is considered to be termination. So what this diagram depicts is in which state of action you are in the process. The next diagram is component diagram. So when we have discussed about component notation, as I earlier told you, it is indicating the part of a system or a component of a system. So component diagram is used to break down a large operating object-oriented system into smaller components. So as to make them more manageable, it models the physical view of the system. So this is considered to be a physical view of the system, such as executables, files, libraries, etc. It visualizes the relationship as well as the organization between the components present in the system. It helps in forming an executable system. So when do we use, what is the purpose of this component diagram? It shows you each and every component of the system. It constructs the executable by incorporating forward and reverse engineering. It depicts the relationships and organization of components. So here product is one component, order is another component, customer is another component, account is one component. Here all these components are interacting with each other. So how these components are interacted with each other is represented through the component diagram. So all these are representing as a parts of a system. The next one is deployment diagram. The deployment diagrams are mainly used by system engineers, and these diagrams are used to describe the physical components like hardware and their distribution and association. So you can see the physical parts of the system. So you can see user connecting with a system like internet, servers, multiple servers. So we are able to see the physical parts of the system in the deployment diagram. What is the purpose of this deployment diagram? To model the hardware topology of a system, and also to model the embedded system, to also model the hardware details for a client or server system, and to model the hardware details of a distributed application. And we can also possible of mentioning forward and reverse engineering. So all these diagrams we have discussed. So these diagrams will be visually, as we discussed, UML, Unified Modeling Language. So this provides a visual description where based on which we can draw and we can identify what requirements to be noticed in order to code or in order to design. So UML is the basic step in order to design your code or an application. So this is for today, and thanking you all.